And you know how you guys have to, like, you guys have trouble setting the window to get stuff? All you have to do on the thing is, this is how you set the window. Like that. You make it smaller, make it bigger. And then you know how you calculate the zero? Or what do you guys have to do on the prism? What is it called? G-solve. All you gotta do, you have the graph on the screen. Whatever. You wanna calculate zero, you just do this. And the thing gives you the zero. If you wanna calculate the math, you just do that. If you wanna calculate the min, you just do this. So next semester we'll be looking forward to that. I think I'm not sure exactly what's going to happen, but I'm going to request they put it on all the iPads because that's a really useful tool. Oh, and then when we study 3 dimensions in the 3rd quarter, that's going to be good. We can graph 3-dimensional surfaces. Woo! Oh, now there's more. Those are sneaky. Okay, H. Y equals 2x squared all over x squared minus 2x. So first thing you gotta do is factor it so because if you can cancel stuff, so this x cancels that, so you get 2x over x minus 2. Okay, so we graph this, x-intercept 0, y-intercept 0, vertical asymptote x equal 2, horizontal asymptote y equal 2. And then, since we got this, it's going to go, and since you crossed out the x, that means at x equals 0, the origin will have a removable discontinuity. What happened? You guys forgot to cancel out the x. But then if you don't cancel out the x, then you think there's going to be a vertical asymptote at x equals 0, but there's not, because it got canceled out. You always have to cancel out the factors before you start. Okay, J. Oh, did you hear that? Didn't come out now. X squared. I'm going to factor the bottom. Okay, here we go. So x-intercept 0. Let me ask you this. If the x-intercept is 0, does that mean the y-intercept is 0? Yes! Where else can it be? You can't put, like, if the x-intercept is here, the y-intercept can't be somewhere else because otherwise it's not a function anymore. Okay, vertical asymptote, x equal 1. Make sure you label all asymptotes anyways. We're going to have a quiz probably Wednesday or Thursday. I guess not tomorrow then, yeah. Thursday then. So, you're going to have to label all asymptotes and removable discontinuities. So I guess over here you got to put 0, 0. Yeah. Okay, horizontal asymptote is y equal 1. Okay, so it's going to look like this. How do I know it bounced off that x-intercept? Even power. How do I know that on this vertical asymptote the thing shoots the same way? Even power. You got to know the difference between odd power and even power. In the numerator, the numerator tells you what the x-intercepts are, and if you have an even power, it bounces off the x-intercept. If it's an odd power, it goes through the x-intercept. The denominator tells you the vertical asymptotes. If you have an odd power, then the thing goes opposite way. If you have even power, they go the same way. So you have all the clues. It's like telling you what to do. And then L, come on. X cubed minus 3x plus 2. Okay, so we need to factor. So the top is going to be x minus 2x plus 1. And the denominator is going to be x minus 1 squared times x plus 2. You have to use synthetic division. I just did it in my head. You guys remember synthetic division? That's how you factor when you have x to the cube or bigger. Yeah. Anyway, I think on the quiz I'm going to go easy on you. I'm going to give you both this and that. I'll give you the multiplied out form and the factor form. Because if you factor it wrong, that's pretty much a fatal error. And we don't want fatal errors, right? Okay, so x-intercept, because there's no canceling here. 2, negative 1. Y-intercept is negative 1. I look at this one. Let's look. Let's do that. See? Negative 2 over positive 2 is negative 1. Vertical asymptote, x equal 1. x equal -2. Since the degree of the bottom is bigger than the top, then y equals 0 is a horizontal asymptote. Okay, so this one here, see I do the middle first because I got these 2 points as clues. How did I know to go through this x-intercept and not bounce off? And how did I know not to come from up there and not from down here? Because if it, look, -1 came from this factor odd power, so it's got to go through. So if you started from down here and you go through, how the heck are you going to hit that point? See, it all makes sense. You just got to have common sense. That's the problem, is the part. That's why it has to start from up here. You come down, go through, hit that, and it's not going to go up because there's no x-intercept there, so it has to go down. Now, -2 came from here, odd power, so that means exploding up on this side will be exploding down on this side, and then what? 1 came from this factor, even power, so if it's exploding down, don't explode down, and then oh, wait, fool. You got to go through the x-intercept, and then now what? And there's the graph. Remember, your horizontal asymptote, as the graph goes out to the left and the right, the graph got to get closer and closer to it. Pterodactyl. Are we getting the hang of this? Okay, any other questions you guys want to ask? Now's the time. So on Thursday's quiz, probably just going to have 5 graphs, 4 points each. Who's on cross country? So you guys not here Thursday. So you take it tomorrow. So you're gonna be gone.
Yeah.
You guys leave Thursday?
Thursday morning.
Thursday morning. So you don't even come to school. Meet at the airport.
Yeah.
What time? What airlines? Okay, today we gotta learn about what happens when the degree of the top is bigger. Well, we know there's no horizontal asymptote, but could there be some other kind of? Yes, okay, so let's do a problem. Oh, you got a whole bunch of stuff here. Now, since this is homecoming week, and there's not gonna be a test, so how many worksheets are there? 4. There's only 4. Okay, so we're going to do those 4 worksheets over 5 nights. You know what I'm talking about? Usually we do 5 worksheets over 5 nights, but we're going to, doing 4 worksheets 4 nights, we're going to do it in 5 nights. So you're going to have like an extra night. So it's up to you what you want to take it, do the math. Okay, so here, y equal x squared minus x minus, give me a number.
5.
Wrong, 6. All over x plus 1. See, the degree of the top is bigger than the bottom. That's still a rational function. So you still go through the 4 steps that I taught you yesterday. So you probably want to factor the top as x minus 3, x plus 2. Can you see why 5 would have been a bad number? Because then it wouldn't factor, yeah? Okay, so what are the x-intercepts? 3, -2. Y-intercept is -6. Right, look at this one, see, -6 over 1. Vertical asymptote, x equal -1. Okay, but now, since the degree of the top is bigger than the bottom, there is no horizontal asymptote, but there is another kind of asymptote. What did we learn last year? If the degree of the top is bigger by 1, you're going to get a slant asymptote, or some books call it an oblique asymptote. And how do you get it? Like I told you yesterday, what does this bar mean? It means divided by. So what you have to do is you have to divide this by this. Now, do you want to do long division or synthetic division? It's up to you, because we both do the same thing. If I were me, I would do synthetic division, because it's faster, except this is a 6-fold. And if I'm going to divide by x plus 1, what goes in the box? -1. So 1, -1, -2, 2, -4. So what does this mean? If I divide this by this, what do you get? You get the quotient, which is x minus 2, plus the remainder over the divisor. You guys remember how to do synthetic division, I hope, right? Now remember, horizontal asymptotes only take effect on here, right, as x approaches infinity or negative infinity. Okay? So same thing over here. What happens as x approaches infinity or negative infinity? What happens when x is a really large positive or negative number? What happens to this? Like if I plug in a billion or negative billion. Doesn't this thing get very close to 0? So we say that this goes to 0, which means you're left with this. So this is going to be your slant asymptote. So your slant asymptote is y equal x minus 2, right here. Y equal x minus 2. You get slant asymptote. So to get your slant asymptote, what you do is you divide, and you just look at the quotient. So y equals the quotient is the slant asymptote. That's because as x approaches infinity or negative infinity, this part here gets closer to 0. Right? And x minus 2 plus something very close to 0 is something very close to x minus 2. So that means same thing. As the graph goes out here, then the graph will get closer to this slant asymptote. So do not be surprised if the graph crosses the slant asymptote somewhere in here. Okay, so same reasoning as yesterday. Is the graph going to be up here, or is it going to be down there? It has to be up here because you got to pass through this x-intercept here. Now, since the thing is exploding up on this side, what? Exploding up on this side or from down? Same thing as yesterday, people. This vertical asymptote came from this factor odd power. So if it's exploding up, it will be exploding down like this. Okay, I'm coming up to this point. What do? Go through or bounce off? You go through. How do you know? Because 3 came from here, odd power. Now what? You get closer to the asymptote. But it's a slant asymptote now. It's not a horizontal. It's a slant. But it's the same reasoning. You guys get it? Oh, and I forgot to tell you. Darn it, we had the thing up on the board too. I forgot to teach you. Okay, let's go back. Let's go back to last night's homework. Suppose you have a graph that looks like this. 1 equal 2. X equal 3. Suppose you have a rational function that looks like this. Okay, we have this notation in mathematics to describe asymptotic behavior. So, what if I were to ask you, what is the limit of this function as x approaches infinity? Have you guys seen this notation before? Last year? You're lying, because I know you did. How did you learn about the number e then last year? What's the number e? Is that what you're thinking? Did you guys learn the number e last year? Why are you saying no? Hanaoka, did you learn the number e? Yeah, and how did you learn it? Because to learn that number, you gotta use this notation, that's why. So I'm wondering how your teacher taught you about e. 2.71828. 182845945, and so forth. How did you learn about the number? Yeah, I know. But how did you learn it? Like, where did this number e come from? Oyana Mari?
No, we didn't.
Ha! Take that, Kwak. You did learn that notation last year. Anyway, whatever. I'll teach you like you don't know anything. The limit of this function as x approaches infinity, that means when x gets really large positive, what happens to the y-coordinates of this graph? In other words, as the graph goes out to the right, the y-coordinates are getting closer and closer to 2. That's how we describe asymptotic behavior. What is the limit of this function as x approaches negative infinity? In other words, as the graph goes out to the left, the y-coordinates are getting closer and closer to 2. And why is that? Because that's the horizontal asymptote. What is the limit of this function as x approaches 3 from the left? Okay, here's x equal 3. Coming from the left, look. What's happening with the y-coordinates? So right here it's like negative 3. Oh, but now it's negative 10. And the thing is just exploding downward like that. So what do you think the limit is going to be? As I get closer to 3 from the left, what's happening with the y-coordinates? The graph is shooting down like that. Negative infinity. That's the limit. What is the limit of this function as x approaches 3 from the right side? So here's x equal 3. Coming from the right, the graph is shooting upward like that. So what do you think the limit is? Infinity. So this is how we describe asymptotic behavior. And it's perfect when you have rational functions. But we use it to describe any kind of function. Okay, one more example. Okay, so if the degree of the top is bigger by 1, you have a slant asymptote. That's because when you divide it, the quotient is going to be degree 1, right? But what would happen if the degree of the top is bigger by 2? Like if you had something like this. X cubed minus 8 over x plus 1. What if the degree of the top is bigger by 2? Then is there a slant asymptote? No. You get a parabolic asymptote. Because when you divide, the quotient is going to be a parabola, that's why. If the degree on the top is bigger by 3, then you're going to get a cubic asymptote. If the degree on the top is bigger by 4, you get a quartic asymptote. And so forth and so forth. And all that means is, as the graph goes up to the left and the right, the graph will get closer and closer to what this is. So I'm just going to let you know that it exists, but we're not going to study it. Okay, so the most you're going to get is just a slant asymptote. I won't give you parabolic asymptote. Oh yeah, I wasn't going to learn it anyway, Mr. Park. Okay, that's the way it's going to be. Okay, so now you guys know how to find the slant asymptote. Okay, let's go backwards. What if I give you the graph, give you information about a graph, and then you have to write the equation? So write me the equation of a graph that has a vertical asymptote of x equal 2, make up something. It has a slant asymptote of y equal, what do you want it to be, x minus 1? Okay. And then, wait, shh. And then the graph also passes through the point. So in other words, it's going to look something like this. And then y equal x minus 1. And then it passes through the point. Okay, give me a point. Any point. 2, 0. But that's, no, come on, but that's the vertical asymptote there. Okay, that's a very bad point.
5, 5.
5, 5. Okay, that works. Okay, 5, 5 is over here somewhere. It passes through the point 5, 5. So that means the graph will probably look something like this. Well, I missed. Just make the point bigger. Okay, write me the equation of this graph. How do you do it? Well, how did we learn how to find slant asymptotes? What do you have to do? You have to divide, right? And when you divide, what do you get? You get the quotient plus the remainder over the divisor. So therefore, the equation of this rational function has to be y equal x minus 1 plus the remainder over the divisor, right? Remember how we did the long division? And the quotient tells you the slant asymptote? This thing here is the slant asymptote. Remainder over the divisor. Okay, what's the divisor going to be? Well, if you have a vertical asymptote of x equal 2, what has to be in the denominator? X minus 2, right? So doesn't the divisor have to be x minus 2 because the vertical asymptote is x equal 2? Yeah, this is it. This is your equation. All you got to do is figure out what the remainder is. How do I do that, Mr. Park? Well, the graph passes through the point 5, 5. Therefore, what do you think I'm going to do at that point? You plug it in. If a graph passes through a point, that means you can plug it in. So if I plug in 5 for y and 5 for x, you can figure out what r is, right? Okay, let's do that. Let's see if this person picked a good point or a bad point. So 5 equals 5 minus 1 plus remainder over 5 minus 2. So the 5's cancel out. Oh, this is pretty good. So r over 3 is equal to 1. So r equals 3. Hey, you picked a good one. Who picked it? Quinto. Lucky guess. So that means the equation, I'm going to erase this now. The equation of this graph is y equal x minus 1 plus 3 over x minus 2. And that's your answer. Except when we're working with rational functions, we want to write it like a rational function. So how do I write it in the form polynomial over polynomial? You make a least common denominator. So what's going to be here? X squared minus 2x. Like, come on, this is like over 1, people. Just multiply by x minus 2. Oh gosh. What's negative 1 times x minus 2? Oh, no. Okay, let's do the algebra 1. Too late. No, let's go back to algebra. X times x minus 2 minus 1 times x minus 2 plus 3. Now we multiply out. X squared minus 2x minus x plus 2 plus 3 all over x minus 2. So your final answer is going to be y equal x squared minus 3x plus 5 all over x minus 2. Kaboy! And that's your answer. So this is going backwards. I give you information. Pretty much all the functions that we're going to study this year, you're going to have problems like that, where I give you information about the graph, you have to write the equation. Or I draw you the graph, you have to write the thing. Oh, that would have been better, yeah. In fact, I did draw the graph. But you're not going to get anything like that on Thursday. You're going to keep it simple. You just have to draw 5 graphs. One of them will probably be a slant asymptote. Or maybe 2. Since I told you 3, 2, 3. Okay, any questions on this? And then wait, there's one more thing on the homework that I have to cover. Let me see the homework. Oh, look at number 9. Should I even teach you about that? I will. Look at number 9. Doesn't that look like a problem we had before? Yes or no? Yes, it does. Remember we did this problem before? Square root of 1 plus the square root of 1 plus the square root of 1 forever. Okay, well, now we have 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 forever. It's the same thing. So I'm going to do a problem like it, which is 3 plus, no. We're going to make it a little more different. 3 over 3 plus 3 over 3 plus 3 over 3 forever. We call this a continued fraction, because the fraction continues. Okay? Well, that's why they call it this. You know who was good at this? Srinivasa Ramanujan. You ever heard of that? Oh, you heard of Srinivasa Ramanujan? No. He's the greatest mathematician in the history of India. No, you could give him a number, any number, and he could come up with a continued fraction that represents a number. Any number. Like 5, and boom, he just writes it out. Square root of 6, boom, he just writes it out. Pi, boom, he just does it. Any number, he can write a continued fraction for it. Srinivasa Ramanujan. Srinivasa Ramanujan. You guys ever watch the show Numbers? You ever heard of the show Numbers, where they use mathematics to solve crimes? Well, one of the people in there was, her name is Ramanujan. What was her first name? Kristen? I thought you said you watched it. What's her name? Oh, her name is, it's on the tip of my tongue. That's like the lead mathematician guy, that's his girlfriend. Her name is, we're not doing anything till I remember it. A, B, C, D, G. Mita. It's Mita Ramanujan. I don't know if she's related to the Srinivasa Ramanujan. Anyway, why are we talking about this? Okay, how do you compute this with what this number is? So what did we do when we had this several chapters ago? I don't know what this number is. I'm going to call it x. Okay, so what is x? 3 over 3 plus 3 over 3 plus 3 over 3 forever. So what you have to do is you got to figure out, where do I see x again? So where do I see x again? Yeah, right there. See, 3 over 3, let's see, because it repeats it twice. So this equation now becomes 3 over 3 plus x equals x. And you can do this because it goes on forever. If it didn't go on forever, you couldn't do it. And then now all you gotta do is solve this quadratic equation, cross multiply. So 3 equals 3x. That was a bad number to pick, 3. Who picked 3? So it's a quadratic equation, x squared plus 3x minus 3. Now we gotta use quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac 21 all over 2. Did I do that correctly?
Yeah.
Okay. So which one is it? Is it the one with the plus or the one with the minus? Obviously, you can see this is going to be a positive number, right? Because there's only plus signs there. It's got to be positive. So therefore, take away that. That's your answer. Does that refresh your memory? Okay, so hopefully you can do number 9 now. I think you can. Okay, we're done. So we were gonna watch some video. What are we gonna watch today? No, we watched that yesterday. We're gonna watch something different. I don't know, did I show you? I think I showed some class. Did I show you the Park Trio? Park Trio at Homecoming 2003. What?
Can I see a flash mob? I never saw a flash mob. You did.
You never saw the flash mob from last year?
I wasn't there.
My PCH classes did flash mob. You guys weren't even there. It was during homecoming. Okay, let's try to find it. Where would it be? It's on YouTube? Okay, we'll try it.
Oh, is that the one you did the Kikaida?
Yeah, we did the Kikaida flash mob. Did I show you the Kikaida halftime show? I did, right?
Yeah, you showed that.
What? I never showed you the Kikaida halftime show? Is it there?
I was there. Forgot.
Oh, we got a lot of things to do then. We got a lot of catching up to do.
Still running.
What's still running? Oh! Yes, we don't want administration knowing I'm showing you home videos.